So today we're going to discuss characteristics of a linear function. All right, characteristics of a linear function. And the first two things we need to talk about is called domain and range. Have y'all ever heard of those two things, domain and range? Yeah? Do you know what they are, or you just kind of heard of it? Not really. Has it been a while? It's just been a while, right? That's okay. Range is just height. That's getting there, okay? So domain deals with all of your x values. Okay, so anything that goes side to side, it tells you what's going on left to right. That's domain. Range is the y values, okay? Everything going from bottom to the top, okay? So domain, x values, left to right. Range, y values, bottom to the top. Make sense? Okay, so now you know what domain and range is. There you go. Yeah, I like that. Domain is side to side, range is up and down. Well said. All right, so when you look at our packet here on page 29, talks about domain, right? All the possible values of x. When we look at a graph, and we'll kind of look at that and what it looks like. And something to think about, how far left to right does the graph go? So really, how far left does the graph go? How far right does the graph go? That's kind of answering the domain part of things. Let's not get too concerned about this right here. We'll worry about that later when we need to. Range, again, just talks about the y values. All the possible values of y. How far down and how far up does the graph go? So, if we have a graph that looks like this right here, right? And it goes this way forever and that way forever. All right? How far left does the graph go? Forever. Good. I'm glad you said that. Forever. How far right does the graph go? Forever. Good. Now let's look at it going up and down. How far down does the graph go? Forever. How far up does the graph go? Forever. And that's kind of the easy part about linear functions. The domain and range for linear functions is always usually the same. Domain is always negative infinity to positive infinity, and the range is negative infinity to positive infinity. There's a couple cases where it's not, but we will look at those. So let's jump down to the actual linear side, because that's really what we're dealing with, the linear examples. So again, domain, right? Domain. How far, if you look at this graph right here, and here's our line, right? How far left is this graph going to go? Just looking at it, number one. Obviously, we see as we move left, it's going up, right? But how far left is it going to go? Forever. So the domain here, and let's look at the right side. How far right is this graph going to go? Forever. Okay, do y'all see that? So the left side means negative infinity. It's going to go to negative infinity, right? It never stops. It goes to negative infinity. What do you think the right side is? Positive infinity. So how we write this is negative infinity to positive infinity. That's how it's written. Okay? Another way of writing it is, or some people put all real numbers. All real numbers. Let me get that. Thank you so much. All real numbers. That's the domain. Just because, again, and all linears are probably going to be have that same idea. So the range. The range here, how far, we do it from the bottom to the top. Bottom to the top. Thank you so much. So how far down does this graph go? Forever, yeah. So And how far up does this graph go? Forever. Do you see the pattern here? Yeah, so that is negative infinity to positive infinity. That's right. Unit 5 packet, page 29. So going down, okay, if it goes down forever, that is negative infinity. If it goes up forever, that is positive infinity. And what is another way of writing negative infinity to positive infinity that I just wrote out? All real numbers, or all real numbers. Does that seem pretty easy? Yeah, that's pretty simple, right? Kind of. Infinity? Oh, really? You just said all real numbers? So just a different way to kind of look at it. You know, it's like, hey man, are those shoes or are those sneakers? You know, they mean the same thing. It's just saying in two different ways. You know. All right. So let's look at number 2 here. Take a look at this graph. How far left does this graph go? How far right does this graph go? Hey, how far down does this graph go? How far up does this graph go? So literally, it's the same exact answer. Same exact answer. So you'll write down negative infinity to positive infinity. And Tim, like you said last year, how did y'all say it? Y'all said it was what? All real numbers. Or all real numbers. All real numbers. Excellent, excellent, excellent. So that's the idea behind linears when it comes to domain and range. Again, not very difficult to understand. And usually they're always the same. It's always going to be negative infinity to positive infinity. Negative infinity to positive infinity. Okay? Do y'all want to look at non-linears real quick and see what they look like? Or do y'all like, I feel good about it. We're good. Don't worry about it. So let's jump into non-linears then, okay? So like if you look at number 1, right? Look at number 1. Notice the line stops, doesn't it? It stops at a certain point. And on the right side, it stops at a certain point, doesn't it? So for domain, if we're talking about left and right, how far left does the graph go? When does it stop? Where on the X does it stop? Like where is that on the X? Well, positive 1 is right here. Negative 1. So our domain would be negative 1. And then how far right does the graph go? Like it stops right there, right? What is that point on the X? Six. Did you get 6? So right here, if I count right here, if I start at 0, 1, 2, 3, 4, 5, 6. Yes. All right. So you have this dot right here. Again, we're talking about how far left and how far right it goes. This is how far left it went. It stopped right here. So when you go down to the X, because X deals with domain, that's where it stops, at negative 1. If you're at 0, it stopped at negative 1. If you look at the right side, how far right does it go? Well, if you bring it all the way back up to the X, it stops right there. So that's at 1, 2, 3, 4, 5, 6. So the domain, it's almost like you're putting the graph in a window. You know what I mean? So my window over here is negative 1. My window over here is 6. It's inside the window. All right? Now let's get our window from the bottom to the top. Okay? How far down does the graph go? What's the lowest point on the graph here? Would it be like right here? If I go over, what am I at? Kind of. A negative 2, yeah. Because if you follow this over, I'm at negative 2. So my range is negative 2. That's my lowest. That's the lowest part of my graph. What's the highest part of my graph? 5. Yes. That's our highest part, right? 1, 2, 3, 4, 5. So my range there is negative 2, 5. That's my range. That's how low the graph is. That's how high the graph is. My domain is negative 1, 6. So now my whole graph is inside this window. Nothing is outside the window. Go ahead, do break. No. You're going to see on the next one that it will not start with a negative. All right? So like on number 2, and I thought, great question, does it always start with a negative? And not the case here. Check out our domain. How far left does the graph go? So, well, it's going up by 2s. Okay, so what would this one be right here? 0, yeah. So 0 is our farthest left point, isn't it? So domain, 0. How far right does the graph go? 24. There you go. Now we look at range, right? Range, we always do the bottom first. What's the lowest point on the graph? 30. What's the highest point on the graph? 80. And that's the answer. Now our domain and range puts our graph into a box, essentially. Yeah, I would say so. Always start at the bottom first. Yeah, good. So I'm going to say that again for all the YouTube subscribers. For range, bottom first. Do the bottom first, yes. Oh, okay. You just want to be heard by the YouTubers? All right, let's do the last one here, and then we'll cut off this YouTube video. So the domain here, remember, domain deals left to right, left to right. How far left did this graph go? So that's 0, 0 right there. 1, 2, 3, 4. Negative 5? Yeah, excellent. Negative 5. Good. How far right did the graph go? I like 8. 8, yeah. No, you're good. Do brush. Check it out. So from right here, right, we got to get to the farthest right point. This is the farthest right. Would you agree? So 1, 2, 3, 4, 5, 6, 7, 8. That would get us all the way to the end of the graph. Okay? Good. Now range. Where do we start range at? The bottom. Yeah, so what's the lowest point on this graph? It's right here. And that's at, yeah, negative 3. What about our highest point on the graph? Positive 2. Positive 2. Yeah, that's our highest point. And that's at positive 2. 1, 2. So again, the domain range just literally just puts the graph in a box. You know, like when we go back down to these right here, right? When you have this right here, the domain being negative infinity and the range being positive infinity, is there really a window? No, because it never stops, right? Because it keeps going forever. It keeps going left forever. It keeps going right forever. It keeps going down forever. It keeps going up forever. So that's why here, when the domain and range is always negative infinity to positive infinity, are all reals. You know, the window goes left and right forever and up and down forever. So, good questions, good questions.